Hi all, and thanks for joining. Today I'm going to walk you through this hands-on lab, storing and rotating RDS credentials in Secrets Manager. The lab is available on QA platform, previously known as Cloud Academy. I'll first read through this description of this lab, then start the lab. Also, after each of these lab steps, I'll do the relevant part hands-on. Let's begin. AWS Secrets Manager is a fully managed service for managing sensitive digital credentials. Types of secrets that can be managed with AWS Secrets Manager include keys, passwords, tokens, and certificates. Secrets Manager can be used with other AWS services, such as CloudTrail, enabling sophisticated auditing and monitoring of secret storage and access. One of AWS Secret Manager key features is the ability to automatically rotate a secret on a schedule. Secrets Manager integrates seamlessly with your existing AWS services. In addition, it can be easily configured to rotate credentials in external or unmanaged services using a custom Lambda function. In this lab, you will store a secret in Secrets Manager, you will update a Python web application to retrieve the secret, and you will enable automatic rotation of the password stored in the secret using Secrets Manager. Learning objectives. This is a beginner level lab. Upon completion of this lab, you will be able to create a password in Secrets Manager, update a Python application to fetch your password, and enable automatic rotation of your password in Secrets Manager. Intended audience are database administrators, DBAs, cloud engineers, and data engineers. Prerequisites. You should have a conceptual understanding of databases and secret management. Knowledge of the Python programming language and the Linux command line will be beneficial but is not required. The following courses can be used to fulfill the prerequisites: Database Fundamentals for AWS, Python for Beginners, and Linux command line byte session. Let's see the environment architecture before and after. And let's start the lab now. As usual, I'll skip reading through this first step. The gist of it will use credentials on the left side panel. Let's proceed to step 2, creating a secret for RDS in Secrets Manager. Introduction. AWS Secrets Manager is a service for securely storing sensitive credentials. In this lab step, you will use AWS Secrets Manager to store a new password for use with an RDS database. Instructions. Ensure you have somewhere you can copy and paste to and make notes in. In this lab, you will be prompted to make notes for use later. Cloud Academy recommends opening a notes page and using it to store notes for the duration of this lab. Then, in the AWS Management Console search bar, enter Secrets Manager and click the Secrets Manager result under Services. Then, to open the form for storing a new secret, click Store a new secret. In the Select Secret Type section, ensure Credentials for RDS database is selected. Enter the following values for the fields below, accepting the defaults for fields not specified: username admin and password lab password 123. Cloud Academy recommends clicking the Show Password checkbox and verifying you have entered the username and password correctly. You will use these credentials to connect to a pre-configured RDS instance later, and they must be correct here for the connection to be successful. In the Encryption Key dropdown, ensure AWS Secrets Manager is selected. The above option specifies to use an encryption key created by AWS. In a non-lab environment, it is best practice to create a customer master key using AWS Key Management Service. Using a key you generate yourself ensures that you and no one else, including AWS, can decrypt and access the secret. In the database section of the form, select Lab Cluster 1. Lab Cluster 1 is an Aurora MySQL cluster that has been pre-created for you as a part of this lab. You will connect to it using this secret from a Python web application in a later lab step. Note, if you do not see lab cluster 1, then check that the lab environment has finished setting up. Once the lab setup is complete, refresh the page and re-enter the details. To advance to the next page of the form, click Next. In the secret name and description, in the secret name text box, enter lab web app MySQL and add a few random characters at the end. Make a note of the name of your secret. You will use the name later when fetching these credentials. You've added the random characters because they may already be a secret with this name. If the name is not unique, you will see a failure notification later when storing the secret. There may be an existing secret with the same name because this AWS account is used by other students in other labs. Although labs are cleaned up after a session, secrets are kept in Secrets Manager for a minimum of 7 days after being scheduled for deletion. In a non-lab environment, it is good practice for you to add a meaningful description detailing the purpose of the secret. For similar reasons, you may also add tags, which are a structured way of describing resources in AWS. To move to the next page of the form, click Next. Under Configure Automatic Rotation, ensure the Automatic Rotation toggle is toggled off. You will enable automatic rotation for this secret in a later lab step. You will see the Review section of this form and below that a Sample Code section. AWS helpfully provides sample code implementations of fetching a secret from Secrets Manager in several different programming languages. In the Sample Code section, click the Python 3 tab. Take a moment to read through the Python 3 sample code. The sample code demonstrates using Secrets Manager's API to retrieve a secret. You will use similar code to update a sample web app in the next lab step. To store your secret, click Store. You will be taken to the secrets list page and you will see a notification that your secret has been created. If you see a failure notification telling you the secret name has already been taken, click Previous twice to return to the secret name and description section, add some more random characters to the secret name, then click Next twice and click Store. Summary: in this lab step, you created a new secret containing credentials for use with RDS. We have one mandatory validation check here, and it checks if a secret has been created in AWS Secrets Manager. Let's proceed to do this part hands-on. Account ID is a match. Let's proceed to username. And lastly, password. I'll search for Secrets Manager service. Let's bookmark it. And let's store a new secret. Secret type will be credentials for Amazon RDS database with username admin and password lab password 123. With this, we successfully stored the secret. Let's run the validation check. Let's proceed to the next step, connecting to the virtual machine using EC2 Instance Connect. Let's refresh this page to see if that will show us next button. There it is. Let's proceed to the next step. Introduction. In the previous lab step, you used AWS Secrets Manager to create a new secret. In this lab step, you will connect to an EC2 instance using EC2 Instance Connect and access a shell. Instructions. In the AWS Management Console search bar, enter EC2 and click the EC2 result under Services. To see available instances, click Instances in the left-hand menu. The Instances list page will open and you will see an instance named Cloud Academy Labs. If you don't see a running instance, then the lab environment is still loading. Wait until the instance state is running. Right-click the Cloud Academy Labs instance and click Connect. The Connect to Instance form will load. In the form, ensure the EC2 Instance Connect tab is selected. You will see the instance's instance ID and public IP address displayed. In the username text box, if it is empty, enter EC2-user. Note: ensure there is no space after EC2-user or Connect will fail. To open a browser-based shell, click Connect. A browser-based shell will open in a new window ready for you to use. If you see an error, it is likely that the environment hasn't finished setting up. When you see the following button, that means the lab's cloud environment has fully provisioned. You are ready to use the virtual machine. Keep this window open, you will use it in later lab steps. You can also connect to the instance using your preferred SSH client and the PPK Windows or PAM Mac Linux key files in the credentials section of this lab. Let's proceed to do this part hands-on, though we do not have mandatory validation checks here. We are looking for Cloud Academy Labs EC2 instance. We have EC2 service bookmark. Let's switch to it. Let's connect to it. That worked. Let's proceed to the next lab step. Updating a Python web application to use Secrets Manager. Introduction. In the previous lab step, you accessed a Linux command line shell. In this lab step, using the command line shell, you will update a simple Python web application to connect to the RDS instance using the credentials you added to AWS Secrets Manager in a previous lab step. Instruction. In the Linux command line shell, enter the following command to list the files in the current directory. ls. app.py is a simple Python web application that attempts to connect to a MySQL database and serves details about its connection attempt as JSON when accessed. And requirements.txt is a file containing the Python modules that the application uses. To view the application, enter nano app.py. Nano is command line based text editor. This simple application has 5 parts. Import statements at the top, a function that returns a dictionary containing hard-coded database connection details. A series of statements that initialize a Python Flask web application. A function that responds to a web request by connecting to a database and returning a JSON response. An entry point that starts the web server. Take a moment to read through this code. You will run and modify it in a moment. To exit Nano and return to the command line prompt, press Ctrl X. To get the IP address of the EC2 instance, enter the following command: curl https check IP amazonaws.com. You will see an IP address in response. Make a note of it, you'll use it to access the application using your web browser in a moment. Curl is a command line tool for making web, HTTP and HTTPS requests. To run the application, enter the following commands: pip3 install -r requirements.txt and python3 app.py. You will see output similar to the following. Note that the application is running on port 5000. Open a new browser tab and enter the following, replacing IP address with the IP address of the EC2 instance you copied earlier. You will see a JSON response like the following. Note that different browsers display JSON in different ways. Yours may not look exactly like the above, but the content will be similar. The JSON response has 3 top-level fields: credentials, containing the hard-coded credentials; DB status shows the status of the database connection; and error message. If there is an error connecting to the database, the details are displayed here. Because the hard-coded credentials are incorrect, the application was unable to connect to the database and shows disconnected for the DB status field. You should be aware that in a non-lab environment, it is very unusual to have an application print out its database credentials. This application is doing so only as a demonstration, and it is not intended to be considered secure. In the command line shell, press Ctrl+C to stop the application. To open a new file, enter nano-secretsmanager.py. Copy the code below, and in the command line shell, press Ctrl+V, Command-V on macOS to paste the code into Nano. Please make sure to copy-paste the code in 2 parts. Copy half of the code, then paste it, then repeat the process for the remaining half. This code contains a function called getSecret that uses the Secrets Manager API to retrieve a secret from Secrets Manager. This code is based on the Python sample that AWS provides. There are 2 changes. The secret name is a parameter of the getSecret function. The getSecret function assumes the response from Secret Manager will always be a JSON secret string. To save the file, press Ctrl+O. Press Enter to confirm, and to exit Nano, press Ctrl+X. To open app.py in Nano, enter nano app.py. Add the following line to the imports section of the code at the top. Import Secrets Manager. Delete the credentials equal hard-coded credentials line and paste the following code in the same place, replacing secret name with the name of the secret you created earlier. Credentials equals secrets manager.getSecret secret name. Note: in Python, indentation is important. This file is using spaces for indentation. To avoid errors, ensure that you indent the line with spaces. Your file will now look like this. The import statement you added is loading the Secrets Manager .py file you created, making the getSecret function available. And you have replaced the hard-coded credentials with a call to the getSecret function, passing in the name of the secret you created previously. To save the file, press Ctrl+O, then press Enter to confirm saving to app.py. To exit Nano, press Ctrl+X. To run the application again, enter python3 app.py. Refresh the browser tab with the IP address of the EC2 instance. You will see a JSON response similar to the following. You have replaced the hard-coded credentials with credentials fetched from Secrets Manager. The credentials now contain some extra fields: DB cluster identifier, the identifier associated with the RDS cluster; engine, the engine of the RDS cluster; and port, the port the RDS cluster is listening on. These fields are populated by Secrets Manager because when you created the secret, you associated it with the lab cluster 1 RDS cluster. The DB status field now displays connected. This means the application successfully connected to the database. If you see disconnected, check that the username and password fields match the screenshot above. If they do not, return to the Secrets Manager and update the secret by clicking on it, clicking Retrieve Secret Details and clicking Edit. Leave the application running and the browser tab with the JSON response open. You will use it again later. Summary: in this lab step, you modified a simple Python application to fetch credentials from AWS Secrets Manager and use them to connect to a database. Let's test out this mandatory validation here, though we expect it to fail. It checks if the application is accessible. Okay, that went as expected. Let's do this part now hands-on. Let's save this IP address in our notes file. Okay, it says it's running. Let's use the IP address we saved a minute ago and this port 5000. Let's see raw data. It now looks exactly like displayed on this screenshot. Let's verify we saved the content. Yes, there it is. We have to replace this row. And let's get the secret name from our notes file. Let's save this and rerun the application. I have invalid syntax error. Let's fix this and remove one equal sign. It works now. Let's refresh this page. Great, we are connected now, as seen on this screenshot. And now let's check again. Great, validation passed. Let's proceed to next lab step, rotating the RDS instance password using Secrets Manager. Introduction. Rotation is the process of regularly changing a key, password, or any other type of sensitive credential, usually on a fixed schedule. Regular rotation is a desirable security practice that reduces the impact if a credential is somehow leaked. In this lab step, you will use AWS Secrets Manager to rotate the password in the secret you created previously, and you will verify that the password has been updated. Instructions. Navigate to the Secrets Manager in the AWS Management Console. In the list of secrets, click the name of the secret you created earlier. To open the rotation configuration form, click Edit Rotation. Toggle on Automatic Rotation. Then, in the Rotation Schedule section under Time Unit, select the days from drop-down and enter 30 in days. Under Rotation Function, select Use a Rotation function from your account. In the Lambda Rotation Function drop-down, select the function beginning with Cloud Academy Labs-Secrets Manager Rotation function. This lab has pre-created the rotation function for you. If you want to rotate the credentials of a non-AWS managed service, you can create a function specifically for that resource. In this lab, the function used a rotation implementation of RDS provided by AWS. To save your rotation configuration, click Save. You will be returned to the page displaying your secret, and you will see a success notification. The Lambda has been configured to rotate your secret every 30 days. To rotate your secret, in the Rotation Configuration section, click Rotate Secret immediately. A dialog named Rotate Secret will appear. In the dialog, to rotate your secret, click Rotate. In the Secret Value section of the Overview page, click Retrieve Secret Value. The Secret Value section of the page will expand, and you will see a table of the contents of your secret. Look for password under the secret key value heading. The value will have changed from lab password 123 to a random password. If it hasn't, the Lambda may have not finished rotating the secret. Click Close, wait a minute, and click Retrieve Secret Value again. Refresh your browser tab with the Python application running from the previous lab step. You will see the password change. Your password will be different. The Python application has fetched the newly updated credentials from the secret in Secrets Manager and used it to successfully connect to the RDS instance. In summary, in this lab step, you configured AWS Secrets Manager to use a Lambda function to rotate the secret you created in a previous step, and you verified that the password has successfully updated. We have one mandatory validation check here if rotation is enabled for the secret. Let's test it out now, though we expect it will fail. Okay, that went as expected. Let's proceed to do the hands-on part. Before I click on Rotate Secret immediately, let's refresh the web page. Let's switch to the Overview tab. Let's retrieve secret value, and there it is. Let's click now on Rotate Secret immediately. Let's see what we have now in Overview tab when we retrieve secret value. And now if we refresh the web page, great, still connected with the latest rotated password. And let's quickly switch to Lambda service page to check out the function we used. And let's check again. Validation passed as expected. Let's proceed to the last lab step, using Secrets Manager with CloudFormation. Introduction. CloudFormation lets you define your AWS resources declaratively as either JSON or YAML, making it easy to manage the repeatable deployments of infrastructure in AWS. In this lab step, we will use CloudFormation to create and rotate a secret in AWS Secrets Manager. Instructions. In the shell, to stop the application, press Ctrl+C. To open the application in Nano, enter nano app.py. In the line that fetches the secret, prefix the existing secret name with cfn/. So the row should now be credentials equals secretsmanager.getSecret cfn/secret name. You have renamed the secret that the application will fetch. This secret does not currently exist. You will create it in a moment using CloudFormation. Make a note of the name of the new secret. To save the file, press Ctrl+O and press Enter to confirm you want to save the file. To exit the Nano, press Ctrl+X. To start the application again, enter python3 app.py. Refresh the browser tab where the application is running. You will see an error, resource not found exception. This is because the renamed secret does not exist yet. Make sure that you leave the application running. Make a note of the following AWS Lambda function ARN, Amazon Resource Name. You will use this ARN in a moment when creating a CloudFormation stack. This Lambda function has been created for you to use in this lab. Feel free to navigate to the AWS Lambda console and examine the function and verify the function's ARN. Make a note of the following Amazon RDS database instance endpoint address. You will also use this when creating a CloudFormation stack. This is the endpoint address of the RDS database instance you selected previously when you created an AWS Secrets Manager secret. Feel free to navigate to the Amazon RDS console to examine the database instance resource and verify its endpoint address. Take a look at the following CloudFormation template. This template creates three resources. AWS Secrets Manager secret. This resource creates a new secret in Secrets Manager. Then AWS Secrets Manager rotation schedule. This resource allows you to specify a rotation schedule for a secret. Notice how it references the secret resource. AWS Secrets Manager secret target attachment. This resource is used to associate a secret resource with an RDS instance. In this example, you are referencing an existing RDS instance, and you can also create an RDS instance using CloudFormation and include it in the same template. Copy the template in the previous instruction to your clipboard. You will use it in a moment. You can download a copy of the template here. I have a pop-up in the background offering me to save the chosen template.yaml. Next, in the AWS Management Console search bar, enter CloudFormation, and under Services, click the CloudFormation result. In the top right of your screen, click Create Stack, and in the menu that opens, click with New Resources Standard. A multi-step wizard for creating a new CloudFormation stack will open. A stack in CloudFormation is a collection of AWS resources. Under Prerequisite Prepare Template, click Build from Infrastructure Composer. To open the AWS CloudFormation Designer, click the Create in Infrastructure Composer button. At the top of the screen, click the Template tab. Make sure the template language is YAML. When AWS CloudFormation was first released, it only supported the JSON templates, and YAML was added later. There is no difference between the two formats in terms of features. The main advantage of YAML is that it is often considered to be more human-readable than JSON. Replace the contents of the template text box with the template you copied earlier. At the top right, click the Create Template, and then Confirm and Continue to CloudFormation button. You will be returned to the Create Stack wizard. You have used the AWS CloudFormation Designer to create a new template. The designer has uploaded your template to an Amazon S3 bucket. You will see similar to the following in the Specify Template section. Your template was successfully imported from Infrastructure Composer. AWS CloudFormation also allows you to upload template files from your local computer. To proceed to the next step, click Next. In the Stack Name text box, enter Lab Stack. Under Parameters, enter the following: Database Instance Host, paste the RDS instance endpoint you copied earlier. Database Instance ID, ensure this is Lab Instance 1. Rotation Function ARN, paste the Lambda Rotation Function ARN you copied earlier. Secret Name, enter the new name of the secret. This must match the new secret name you entered when you edited the app.py file earlier. Parameters are a way of passing values into a CloudFormation stack. Using parameters, you can use the same stack template to create multiple pieces of infrastructure. To advance to the next step of the wizard, click Next. This page allows you to specify a number of options, including Stack Policy. A stack policy can be used to protect specific resources from being changed when creating or deleting CloudFormation stacks. Notification options. You can configure a CloudFormation stack to use an SNS topic for notifications of CloudFormation events. Stack creation options. These options allow you to configure rollback strategies and enable or disable termination protection. Leave the options on this page at their defaults. To move to the next page of the form, click Next. The review page will load. At the bottom of the page, click Submit. You will be taken to the stack list page, and you will see that your stack's status is Create in Progress. Wait approximately 30 seconds and click the Refresh button. The status of your stack will change to Create Complete. If the stack status doesn't change, wait another 30 seconds and refresh again. Refresh the Browser tab for your application. You will see credentials, but the database status will be disconnected. This is because the application is trying to connect to the database instance with a completely new password. The password for the RDS instance is currently set to the value of the secret you created manually. Then navigate to Secrets Manager in the AWS Management Console. You will see two secrets listed. The first one you created manually using the AWS Management Console, and the second one you created with CloudFormation. Click on the secret beginning with lab/. Click Retrieve Secret Value. Copy the value of the password field. This is the current password of the RDS instance. To return to the secrets list, scroll to the top of the page and click Secrets. Click on the secret that begins with CFN. /. To see the contents of the secret, click Retrieve Secret Value. To edit the secret, click Edit. Click the plain text and replace the existing value with the password you copied from the first secret. To save the updated password, click Save. Refresh your browser tab with your application running. You will see the DB status field changed to Connected. The application is now using the secret you created using CloudFormation to successfully connect to the database. Summary. In this lab step, you created a secret using a CloudFormation template and updated the Python application to use the new secret. In this lab, you created a secret in Secrets Manager, updated a Python application to fetch the secret, enabled rotation for the secret, and finally you used CloudFormation to create a secret. Let's test out this validation check. It failed as expected. Let's proceed to the hands-on part. We'll add here prefix cfn / and that's all for now. Let's rerun the application and we expect to see this error, resource not found exception. Let's verify this ARN. Let's check the list of functions. We have one function. And ARN is here. Let's copy this function ARN. And let's verify this Amazon RDS database instance endpoint address. There it is. Let's save it in our notes file. Let's create a new CloudFormation template with this code. Okay, looks good for now. We have status create in progress showing. Let's refresh this page. Okay, we have some creates completed. Let's give it some time now. And let's test out the web app now. We expect to see disconnected showing. Yes, as expected. And let's copy the lab secret value to CFN secret value. And after that, we expect the DB status field in web app to change to connected. Let's refresh this page once again. Great. It shows connected as DB status. And let's finally rerun this validation check. Great. With that, the lab is completed. I hope you enjoyed this walkthrough. Bye for now.